All right, welcome to the first geometry lesson in the Thompson's Math series on YouTube. So I like to start these videos off with a page of notes first. For this lesson, lesson 9-6, the first page of notes will actually be question number 1. So if you haven't already, load up Canvas, go ahead and load up the lesson 9-6. And we're going to be looking at question number 1. So these first 4 theorems are important, specifically this one. You're going to be using these throughout this lesson, throughout the practice, and for the other lessons later. So just get familiar with them. They're basically definitions. So, Theorem 9-1. A translation or rotation is a composition of 2 reflections. What that means is you can make any translation by just putting 2 reflections together. So we will see that later on in some of the problems, but just know that translation can be made up of 2 reflections. Okay, so Theorem 9-2. A composition of reflections across 2 parallel lines is a translation. So again, it goes back and forth with this one. So a composition of reflections across 2 parallel lines is a translation. Theorem 9-3, a composition of reflections across 2 intersecting lines is a rotation. So now if we have 2 reflections that are not over parallel lines, they're just 2 intersecting lines, it becomes a rotation instead of a translation. So I want you to notice that we can make all of these using a composition of reflections. All right, Theorem 9-4. In a plane or a graph, one of 2 congruent figures can be mapped onto the other by a composition of at most 3 reflections. What this says is that if you have any 2 shapes, let's take triangles for example, that are congruent, so you have 2 triangles that are congruent, and they're in 2 completely different spots of the map, I can map one onto the other with at most 3 reflections. All right. Now, going on to the second part of question number 1, we have these pictures. So this one represents a reflection. This one represents a translation. Notice it just slides R. This one is a rotation about this point, so it's important to know that we had R and we rotated it. Okay, glide reflection. This is the only kind of new one for you guys. So glide reflection is you glide and then reflect. So it is a translation and then a reflection. So you basically combine these 2 to make a glide reflection. And order does not matter. We will see that later on, but just so you know, you can reflect first and then glide, or you can glide and then reflect. You end up in the same spot. So again, we will cover that later. So as you're filling out the boxes, your answers should be as followed: box 1, box 2, box 3, box 4, box 5, box 6, box 7, and box 8. All right. So I hope that was very clear, and let's get on to the actual problems now. So question number 2, C notes. So the problem number 2 says a glide reflection is a composition of a glide, or translation, and a reflection across a line parallel to that. So if we look at question number 1, specifically here, it says a glide reflection is the composition of a translation and a reflection. That is true. So number 2 is true. Okay, moving on to question number 3. Now this one's a doozy. So it says we have composition of reflections in intersecting lines. Now if you guys remember from the notes that I just showed you, a composition of reflections across intersecting lines creates a rotation. So here we go. it says the letter D is reflected in the line X and then in the line Y. Describe the resulting rotation. Find the image of D through the reflection across line X. Find the image of the reflection through another reflection across line Y. I know, a lot of information right there. It's not too big of a deal. What you're after is looking at the picture they give you, okay? And let's go through the answers. So it says, right under the graph, it says the composition of two reflections across a line, across intersecting lines is a, well, let's look back to our definitions. The composition of reflection across two intersecting lines is a rotation. So our first answer is rotation. As you can tell, I completely messed up right there. Deal with it. Number 2, it says the center. I said number 2. I broke these into numbers. We're still on number 3. I just broke the answer boxes into their own separate numbers to make it more clear. So we're on answer box number 2. So the center of rotation is the point where the lines intersect. So that is your answer. That's what you put in. But what does that mean? That means if you have any two intersecting lines, that intersection point is going to be the point of rotation. Okay? Now, third answer box. And the angle is twice the angle formed by the intersecting lines. That is huge. That is the biggest part from this problem to take away. It says, and an angle, so the angle of rotation is going to be twice the angle formed by the intersecting lines. So if we look at it, we see an angle of 43. The angle of rotation is going to be twice that. So 2 times 43 is 86. So the letter D, so on our fourth answer box, so the letter D is rotated 86 degrees clockwise. Again, we got 86 by taking the angle of intersection and timesing it by 2. Now, the answer box 5 says, or 274 degrees counterclockwise. So if we rotate it this way, it's 86 degrees. If we rotate it this way, it's 274 degrees. Why is that a thing? Well, we have 43 here, but what's this angle? What's this angle right here? Do they not land on a straight line? Yeah. So they're supplementary. So while this is one angle of rotation, or intersection, this is also an angle of intersection. So we could use this angle, which is supplementary, so 180 minus 43 would give us this angle, and then we double that to get 274. All right, again, I don't want you to get too caught up on that. This is the key here, twice the angle formed by the intersecting lines. That is the key. All right, moving on to the sixth answer. This one is very simple. It's just asking with the center of rotation at what point. Well, what is the center of, what letter did they assign that center point? A. So, now I drew this graph out, and I don't have colored pens and stuff, so I did D prime and D double prime, and I wanted to go over that even though it's not included in this problem right now, because you will see it later on. So, anytime you do anything to a shape or a letter, you change it and give it a prime. So, I reflected it once, gave it a prime, reflected it again, gave it 2 primes. That's what those little notches mean. So this would be D prime and D double prime. So I hope that makes sense. We are going to see that more. Just know that this means I moved it once, this means I moved it twice. If I had 5 lines, that means I moved it 5 times. All right, moving on to problem number 4. So, most of this problem is already done for you, but you will have to do this by yourself on your practice. So there are a few things I want to point out. So you're given a triangle, okay, so look at problem number 4. You're given a triangle, and they give you the vertices for that triangle, the points, -4, 5, 6, 2, and 0, 0. And they tell you that you're going to apply a glide reflection to this triangle. So what we do first is we're going to translate it, and then we're going to reflect it. So they already translated it for you, but I am going to go over it and kind of explain what they did. So when we translate something, it will give us a rule. This rule says for every x and y value, do this to those values. So this says the x value is just going to be normal, it's not going to change. The y value, whatever it is, we're going to add 2 to it. So point A, the x value stayed the same. Y value, we added 2. 6, the x value stayed the same. Added 2 to the y value. X value stayed the same. Y value, we added 2. So again, it breaks it down in that little highlighted gray box on how to do the translation. But I wanted you to know that they actually did that before. You will have to do that on some of the other problems that you're going to encounter. Now, next, reflect this triangle across the line x equals -1. So I went out and I drew A prime, B prime, and C prime. I mapped out these points. So what we're going to do is we're going to reflect it across this line right here. This is x equals 1. So how do we do that? Well, the rule of thumb here is you take a point and you count how far away from this line it is. So in this case, A is -4, 7, and it is, from this line, 5 units away. -4, -3, -2, -1, 0, 1. 5 units away. So if we want to reflect this, if it's 5 units away from the line, we need to put it 5 units past the line. So A is going to go from here to here, somewhere about here. Where exactly? Well, how far away from x equals 1 was A prime? It was 5 units. So how many units past x equals 1 it doesn't need to go? 5 units. So I want you to know, we're flipping it horizontally. So what value are we going to change? Are we going to change the x values or the y values? What changes when I move this way? Do I get any higher or lower when I move horizontally? No. The only thing that I'm changing is the x values. So when I go down here and I change A prime to A double prime, so as I reflect these points, I'm changing the x value, but I am not changing the y value. So how do we get these new x values? Simple. Figure out how far away from this line it is and add it. So -4 was 5 units away from 1. It needs to go 5 units past 1. 5 plus 1, 6. So far, so good. Zero is, let's see, where are we? Right here. So we have, oh, sorry, I'm looking at B. 6, 4. How far away is it from x equals 1? Well, if the x value is 6, it is going to be 5, 4, 3, 2, 1. So 5 units away from x equals 1. So if it is 5 units away, we need to go 5 units past. So what is 1 minus 5? -4. Again, the y value didn't change because we're moving horizontally. I'm not raising or lowering any of my values. So now we're moving on to C prime, this point right here. How far away from this line is C? Well, from 0 to 1, it's only 1 unit away. So we just need to go 1 unit past. So what is 1 unit past? 1. 1 plus 1 is 2. So your first answers are 6, 7, -4, 4, and 2, 2. Now, if this didn't make too much sense for you, that's okay. This is your first first attempt at this, and reflections usually give people the most trouble. Just remember the rule of thumb here is if you're moving horizontally, so if you're moving across a line that says x equals something, you're not going to change the y value, you're only going to change the x values. If you move across a horizontal line, so you flip vertically, you're going to change the y values. So if you flip across something that says x equals, you change your x values. If you flip something that says y equals, you flip your y values. You change your y values. How do you change them? Count how far away your point is from the line, and then go that much further past the line. If you're going left, you're going to subtract. If you're going to the right, you're going to add. So I hope that makes sense. Again, I think after doing one or two of these problems, it'll be very clear. All right, going on to number 5. This is a two-part problem, and both are true or false answers. So they're both definition problems, so let's read through them. Counterclockwise rotation of R, so counterclockwise, about point C through the angle 2 times the measurement of angle ABC. So they're saying we're going to rotate R, and it's going to be 2 times the measure of ABC. A, B, C. So what is ABC? And we really have to look at this statement right here. This statement is what we're after. What is the middle letter? B. So that's the one we have to hit. That's going to be our center of our angle. So they're saying A, B, C. That's not really that great of an angle. That is the mistake. So if they were to have said ACB, that would be correct. If they were to have flipped C and B, that would be correct. Because remember, based on our notes, it is twice the measurement. The 2 times part is correct. They mixed up these 2 letters. That's why I say it's very, very important to have these in order. So is this true? No. It is false. Going on to the second part of number 5. So we're still on number 5. We're just on the second part of it. R is drawn between the lines L and M and is reflected across L and then across M. So it's saying you have R, here's L, here's M. We reflect it across L, then we reflect it across M. So this results in a translation half the distance between L and M. So if I reflect R this way and then this way, it does result in a direct translation. So R can translate onto R double prime pretty easily. Now, is this distance half of this distance? No, that's where the false statement is, right here. It's not supposed to be half, it's supposed to be twice. So this is also false. All right, moving on to number 6. All right, I had to cut the video. My dog was going crazy. So let's get back at it. So problem number 6. What we are going to be doing is it asks us to do a glide reflection on the triangle TEX. So again, we're going to translate and then reflect. So we're going to translate our triangle x plus 1 comma y, or just over 1 unit to the right, and then we're going to be reflecting it across the line y equals -2. So the first answers for this problem is just the vertices of the triangle in its standard spot. So you're supposed to look at the picture and you're supposed to count left and right, up and down, and get your coordinates, your x and y coordinates. Now, I know some of your guys' graphs don't load up correctly. That's why I drew out a beautiful straight lines, beautiful axes, and a beautiful triangle, beautiful dotted line. I will stop saying beautiful now. So I went ahead and I already listed the vertices for you. So T, if you wanted to know how to find it, you would go over 1, 2, 3, 4, 5. So -5, and then we go up to -5, 2. You do the same thing to find E, and you do the same thing to find X. So your first boxes that you need to answer, t would be -5, 2, e would be -1, 3, and x would be -2, 1. So I hope that's very clear. Now what we need to do is we need to translate and then reflect. So step 1, translate. Now luckily it only has us answer for the point t. So we are only going to be focusing on those coordinates. So let's plug them into the rule it gave us and see if we can solve this. So translate all of the x coordinates, x plus 1, and the y coordinates we leave alone. See, there's no plus or minus, so we're just leaving it alone. So I went ahead and put in -5 and 2 for x and y, and then I substituted them into the rule above. So -5 plus 1 simplifies to -4, and 2 we didn't need to do anything for. So to answer the question, what is the t coordinates after we translated, or what are the coordinates for t prime? They would be -4, 2. So that part is now done. Now what we need to do is we need to take this point and reflect it. So I went ahead and drew more perfect lines. See, I didn't have to say beautiful. Perfectly straight lines. And I drew out t prime after we've moved it over. So it is currently at the coordinates -4, 2. Now, before we go into anything else, we're going to reflect it vertically. Since this is the line, we're going to reflect it this way. Do our x values change? Did my x value change? No. So my x value of -4 is going to be the same in my answer. So all I need to do is find the y value. How do we find the y value? We need to count how far away t prime is from this dotted line and then go that much past the dotted line. So it is at +2, so we need to go 1, 2, 3, 4 units to find the line, which means we need to go 4 units past the line. So 1, 2, 3, 4. This will be t double prime. What is that y value? -1, -2, -3, -4, -5, -6. So our y value will be -6. So what are t double prime's coordinates after reflecting? -4, -6. So I hope that was very clear. And then now the final part of this problem, it says, would these coordinates be any different, these final coordinates, is if instead of translating and then reflecting, we reflected and then translated. So if we reflected this, we would be changing our y value and then our x value. The way we originally did it, we changed our x value and then our y value. So for a glide reflection, does order matter? That's what it's asking. Does order actually matter? And the thing is, and I'm sorry, I phrased this incorrectly. Does order change the values? They do not change the values. So would it be the exact same coordinates? Yes, they would be the exact same coordinates. Order doesn't matter with glide reflections. Order does matter with other things, but with glide reflections, it doesn't matter. So again, this is a little tricky because you'd want to say no, but the answer is yes, order doesn't matter. And that is it for the lesson. Thank you for staying with me. I'm going to throw these definitions back here one more time for you. You can pause the video or just come back to it when you're doing your homework and your practices. This will give you pretty much all you need to know in order to answer those questions. So if you encounter anything that confuses you or you're still struggling, feel free to email me and I will go further into detail. Otherwise, you can join me on Tuesdays from 10 to 12 in tutoring. Thank you and have a great day.